This puzzle is called Metrocity by AnalyticalNinja. I got it from the Sudoku testing submissions channel of the CTC community Discord. Let's take a look at the rules. So digits in cells, it's skyscraper rules. Digits in cells represent the height of skyscrapers. Clues outside the grid indicate the number of skyscrapers visible. From that clue along the respective row or column where taller skyscrapers obscure smaller ones. Okay, I'll give you an example, but first, all question mark clues represent the same number. Okay, so let's we'll look at this column here, and we'll just do a random configuration of cells 2, 1, 3, 4. So if these were all skyscrapers, let's say this was a 2-story tall building, this was 1-story tall, this was 3, this is 4. So you're standing here, probably back a little bit. How many buildings would you see? Well, you would see this first one. You'd see the 2, of course, it's the first one. But the 2 would block out the 1 because it's taller than the 1. So you wouldn't see the 1. But then you would see the 3 again because the 3 would tower over the 2. And again, the 4 would tower over the 3. So the skyscraper clue for this column from here would be a 3. However, if you were standing over here, you would only see the 4. You wouldn't see anything else because the 4 would block everything. Let's just switch these around real quick. So now we've just switched these around. Now what happens if you're standing here? You would see the 2, but not the 1. You'd see the 4, but not the 3. So this would be a 2 clue on this side. And on this side, you'd see the 3 and the 4, but then the 4 would block out everything after it. So this would also be a 2. So those are just kind of some examples of how skyscrapers work. We're going to need all of these skyscraper amounts to be the same. And then also the gray circle is odd. So odd is just, 1 or 3 for 2x2s. I'll put a link to the puzzle down in the description if you want to give it a try yourself. Yeah, let's give it a go. So I'm thinking here what the skyscraper what the outside number could be. Sorry if you can hear my chair. It is a very loud chair. If I even think about moving, it just starts squeaking the heck out of everything. Okay, so is it possible that these numbers... Okay, well they can't both be 1. It definitely can't be 1. It's a number 1 to 4. That's definitely true as well. So it's a number from 1 to 4. It can't be greater than 4. It can't be 1 because 1 would mean that you need a 4 right away. And so you put the 4 to satisfy this clue, which will block everything. But then this side you can't put another 4 to block everything. So it can't be a 1. It can't be a 4. A 4 would imply, for this row, it would be 1, 2, 3, 4. Because you need to see all 4 of the digits. But you can't obviously do 1, 2, 3, 4 this way, because then this way won't work as well. So it's 2 or 3. Is it possible to have 3 in both directions? I don't think so. I don't see a way to do that. Because 3 in one direction means it's basically in order except for one swapping of things. So it could be well, let's do it downward. So it could be 1, 3, 4, 2, but then this is only 2. Do opposing skyscrapers always add up to 5? Do they always add up to 1 plus the opposite side? I think that's actually the case. If we do 1, 2, 3, 4 like this, then this side will be a 4, and this side will be a 1. Let's say we swap those around, this side will be a 2, this side will be a 3 because it sees 2, 3, 4. Maybe that's the case. They always add up to... No, that can't be the case, because these two digits have to be the same, which means they add up to... Right, because we could just have... Right, if we did 4, 3 like this side would be a 1, and this side would be a 2. Because we see the 3 and the 4. So that's not going to be the case. But it's not possible for 3 and 3, I don't think. So I think it must be 2 and 2. Okay, so maybe... I think it must be 2 and 2. I'm not 100% convinced, but I don't think it can be 3 and 3. And it definitely can't be 1 or 4. So I think it must be 2. So how do we make this clue be 2? If we put a 3 here, I think we've already broken the puzzle. Because if we put a 4 here, then this clue is going to be 1. So this clue is definitely not 4, which means the 4 is going to be over here somewhere. And this has to be something that's less than 3. And now we've broken this already again, because this is going to be at least 3, or exactly 3 skyscrapers it sees. It sees the lowest one, then it sees the 3, then it sees the 4 somewhere back here. So this must be a 1. But after that, I don't... Well, this can't be a 4. I guess, what... No, I was going to say, well, what 2 skyscrapers does it see? But it doesn't necessarily need to see the 3, because the 3 could be hidden behind the 4, and then put a 2 there. That would work just fine. This is definitely a trickier one. Maybe because I'm not super familiar with skyscrapers, but this is tricky. Okay, so we know this is not a 4. We know this is not a 4, so this is a 2 or a 3. So it's going to see this clue. And I guess, so we know 4 is over here somewhere. And if this is the 4, anything could be here. If the 4 is over here, then this must be a 2. So this is a 2 or a 4, this is a 2, 3, or 4. Yeah, I don't know if that's... how helpful that is. Okay. Well, this can't be a 4. Yeah, where can we put a 4 in this column? We've said before, if you put a 4 right next to the wall, then it's going to have just one, it's just going to see the 4. So it just would have a 1 clue. So this must be the 4, which means this is a 4. We have a 4 down here. Okay. So these are 2 and 3. And now no matter what, these clues in column 2 are satisfied. Because this side will see whatever this small digit is and then the 4, and this 1 is hidden behind this one no matter what, so it's always... these clues are always satisfied. Okay, what about this side? What could this number be? I don't think it can be a 1. If this was a 1, we're going to have the same situation we talked about kind of first thing when we were looking at putting a 3 here. If we put a 1 here, this person would see a 1, it would see the 2 or 3, and it would see the 4. It could even see all 4 of them if we situated it even worse, but at best, it sees the 1, the 2 or 3, and then it sees the 4, which is a 3, and we said that this must be a 2. So this can't be a 1, can't be a 4, must be a 2 or a 3, which puts the 1 there, makes this a 1, 4. And I guess we know that there's... so this is a 2, 3, there's a 1 up here, 1, 2, 3. Okay. Okay, so again, this digit can't be less than this digit. If we do 2, 3 like this, then it's going to see a 2, it's going to see the 3, and then it'll see the 4, which is too many skyscrapers. So this must be 3, this must be 2. So it'll see the 3, and then it'll see wherever the 4 is. So then we just, by Sudoku, we can figure out a couple things. This must be 4, this must be 3, which is actually just going to resolve the rest of the puzzle. There we go. Let's just double check, because I'm not sure that I did this correctly. This needs to see 2, so it sees the 2 and the 4. The 1 and the 3 are hidden. This sees 2, it sees 3 and 4, with the 2 and 1 hiding behind the 3. This sees the 2 and the 4. This sees the 2 and the 4, and this sees the 3 and the 4. Yeah, that works. That was a tricky one. That was the hardest one Analytical Ninja has posted, I think. At least off the top of my head. Definitely tricky. But thank you very much for that puzzle, Analytical Ninja. Nice to try out all these different variants in a pretty easy form, to try to increase my familiarity with them. Yeah, so thank you for the puzzle, and thank you all for watching.